I'm Bob Warfield from CNC Cookbook, and today I want to talk about how to prosper with high mix, low volume business. What is high mix, low volume, often abbreviated to HMLV? Once upon a time, most machine shops were high volume, low mix. They got in orders asking for large quantities of relatively few different parts. Everyone wanted quantity discounts, and by optimizing production over a large batch, shops earned profits and more business. But that changed. A lot of the high volume business was offshored to lower labor rates. What remained were unique jobs that emphasized smaller batches and faster turnaround. High mix, low volume jobs have much more variety of parts made in smaller quantities. The quantities are small enough that most of the time you're done with them before there's a chance to optimize our way to big profit. In fact, most shops find it much harder to make a good profit on high mix, low volume jobs. Let's define it a little closer. Datron says low volume is any job for under 1,000 parts. But if we look at statistics across all shops in the US, we see an average batch size of just 95 parts. How do you succeed in a world where you have to get it right with just 95 parts? Let's start by analyzing what's different in the mindset of these two different styles. High volume, low mix is all about optimizing for a particular part. But here's the big difference. High mix, low volume is the art of performing optimizations that'll improve all jobs, not just specific jobs. That's a very important distinction, so let's say it again. Focus on changes that improve all jobs, not just specific jobs. The other thing is that HMLV has a small margin for error. If you're only making 95 parts, you can't scrap many. HMLV has to be right the first time. Once you've wrapped your head around how differently this game works, now you can figure out how to win. I like to think about optimizing HMLV in 4 steps. Number 1, reduce cycle times. Number 2, eliminate uncertainty and surprises. Number 3, automate routines. Number 4, loading and setup optimization. You put those 4 letters together and you're ready to get real about HMLV. Let's drill down on each step and see how it works. We'll start by looking at how to reduce cycle time. Remember, we're looking at changes that impact all jobs. So we're not going to worry about the details of specific jobs, at least not at first. Let's start with better feeds and speeds. I talked to thousands of CNCers about improving feeds and speeds, and surveys indicate that adopting a good feeds and speeds calculator like RG Wizard can bump your tool life by as much as 50% and increase feeds and speeds by as much as 40%. Adopting good feeds and speeds software is an easy step to improving your HMLV results. Better tooling is another. By spending a little more on your tooling, you can improve your cycle times across the board. Likewise, if your CAM doesn't offer the latest tool paths or you're not using them all to their fullest potential, now is the time to up your game. Offline tool setting can also improve your cycle times because you don't have to stop the spindles to do it. Lastly, if you're contemplating new machinery, look for things about those machines that can improve any job. Machines with faster rapids, faster tool changes, more acceleration, those things will speed all jobs up. Being able to put more tools on the machine as well as being able to change tooling while the machine continues making chips, both benefit all jobs. And if you haven't already, look into 4th axis with tombstones so you can cut more sides with fewer setups. All right, let's talk about eliminating uncertainty and surprise. Remember, we talked about getting HMLV working right the first time. Eliminating uncertainty and surprise will surely help that. If nothing else, stable processes are much easier to optimize. Here's a good list to start with for this one. Make sure your G-code runs right when you put it on the machine so you're not wasting valuable spindle time cutting air. That means using a simulator on every job. Make your workpiece and fixture locations repeatable with fixture plates. Figure out how you can cut to tolerance without having to take test cuts. You may have to have better tooling, different programming, different feeds and speeds, or some kind of in-process probing to automate those test cut adjustments. Make tool wear predictable so you can pre-plan tool changes instead of being surprised when a tool breaks. And how about standardizing your tool setups? Maybe the first 20 slots out of 30 in the tool changer are the same for every job. Get consistent materials and standardized material cut sizes and grades. That creates a whole lot of consistency across all jobs. Inspect to identify problems earlier. And lastly, plan for emergencies. Keep a couple of your pallets set up with vices so you can rework and do one-offs quickly as needed. Let's talk about automating routines. And by that I mean automating routines that every job needs to go through. Probes enable a lot of automation around setup, tool handling, adjusting cuts, and in-process inspection. Standardized routines can be almost as valuable. A well-documented standard routine is not only done faster and with fewer errors, but it's the perfect place to start for further optimization. Fixtures offer huge opportunity for standardization once you realize your goal is to create general purpose fixtures that are not part specific. Some of you are going, how is that even possible? Think about standardized material sizes as your starting point. You can whip up a plate fixture to hold different standard material sizes and reuse it across many jobs. Think about how you would standardize repeat jobs. Are you able to leave those jobs set up on pallets so you can bring them back in and pick up where you left off if they reorder? Think about standardizing chip and coolant management so they happen while the machine is running. Your operators can check coolant, clean chips, and top off the coolant while the spindle is still making chips. Make sure your chip augers and conveyors are set to run automatically as needed, and think about any other preventative maintenance that can be happening while the spindles are running. Last part of getting real for HMLV jobs is part loading and setup optimization. Your first job is to invest in pallets so parts are loaded and unloaded while the machine is making chips on the next batch. Once that's done, standardize, organize, and optimize the work. Use checklists and standard fixtures. Follow Lean Manufacturing's 5S to organize and make things visual. Stop searching for the tools you need to set up and keep everything right with the machine. Got all that working great? Start looking at changing from hand tools to power tools, air or electric for part loading and unloading from the pallets. Provide help loading and moving heavy pallets. There's a lot to be gained from optimizing all the work in this loading and setup area. Hey, that's it. Now you've got the high mix, low volume mindset. Be sure to check the CNC Cookbook and Cutting Tool Engineering websites for more valuable HMLV information. I'm Bob Warfield, the CNC Chef. Thanks for listening, and I'll be back soon with another great CNC Chef video.